Hello and welcome to today's video. What you see before you is the schematic, or my proposed schematic, for the Solectria E10 Lithium-Ion upgrade. So I'll go do a quick little overview here. Essentially this section up in here, right here, this middle, will be the front battery box. This section over here will be the rear battery box. We've got the right-hand corner here, we've got some multifunction displays. We have some switches, inputs for that'll be on the dash, or not the dash, but like below the light switch in the truck. I'll actually, if I've got some time, if I remember, I'll go show you where all these are going to go. Then in the back here, we've got our two motor controllers. We've got, let's see, this whole section right here is essentially the battery charger system. We've got a center console system, and we've got a DC to DC converter that takes care of our 150 volts down to 12 volts to charge our battery. We've got an auxiliary battery, and then these are optional. I don't know if I'm going to do that yet, but they're essentially boost converters that take the 150 volts and boost convert up to 380 to power the battery heaters. But I don't know if I'm going to do that. Might just bridge rectify 240 AC and run them through there, or I don't know. still debatable whether I'm going to do that or not. But we'll just zoom in here to the Leaf BMS here. I didn't draw it, but of course this is measuring all the batteries, all the individual cells. I'm going to be using, out of the 48 modules that come in a pack, I'm using 40 modules. So there'll be 20 modules here, 20 modules here. So that's 40 cells and 40 cells that the BMS is reading. I only just drew in the two wires. The BMS controls the relay, which turns on and off the heater. That 380 volts is either going to be bridge rectified to 40 AC, or maybe I'll do a 150 volt boost converter up to 380. I haven't quite decided yet on what to do. The 380 is what the Leaf powered their battery heaters at, so 150 is not going to be enough. This is the modified BMS. You've seen it in other videos. I've replaced the microcontroller, put my own in there, and that's going to be connected via CAN bus. I should probably mention that the thicker wires here are the high current 150 volt type wires. The smaller ones are just like small signal wires, and the blue wire here is like that's CAN bus. So you can see the Leaf BMS is on CAN bus. It'll just spit out all the cells. It'll sit there and read all the cells out and just spit those out over the CAN bus, so anybody that needs to use them can use them. I haven't decided yet if I'm going to do it the same way they did it in the Leaf. I'm debating this. I might do everything in the extended CAN bus, or extended address range on CAN bus, just to prevent collisions. It seems like all the automotive guys, the real automotive stuff, is down in the standard address range, so I don't know, I haven't decided. It's not written in stone yet. But down here we've got, of course, the exact same thing. So up there was stack A and B, and then we got stack, or pack C and D. They got their own battery heaters, their own BMS, and another relay to turn on and off their heaters. So yeah, that's pretty simple. Next we've got this section here, which is the power controller. So this is something that doesn't exist yet. I'm going to have to make it. It's going to be a little box circuit board in there. What it does is it talks over CAN, and it will get the battery voltages and everything from the BMS. The BMS in the Nissan Leaf does not control the contactors, and this power controller essentially is going to be controlling these two contactors. I've also got, it also controls these pre-charge circuits, so there's a 50 watt, 50 ohm resistor, and this will be a solid state, a relay that I'll just make with a photo. It's a little diode that shines onto a photocell, which turns on the gate. They're not very fast switching, but they'll work fine for a pre-charge. With the 50 ohm resistor and 150 volts, you're only talking 3 amps, so that's well within reason of doing that solid state. Now the contactor, of course, is going to be handling a couple hundred amps, and yeah, I'm fusing each pack at 200 amps. that will be using these power bus fuse. What is this? A bus tele power fuse. TPL BH 200 amps. Good for 170 volts DC or less. At 4.2 volts, we are at, gosh, it's really close, but I think we'll be okay. Yeah, if for some reason I charge the 4.2 volts, which is like really high, times 40 cells, yeah, we're at 168 volts, so we wouldn't be up that high. I think I would only ever charge to like 4.1 max times the 40. Yeah, we're down to 164 volts. That should be fine. Not a big deal. And I've got a bunch of these fuses, so yeah. These are all... actually, I think like 3 of them came from the Hamvention, and the rest I got on eBay just because, well, I needed 4, because there's, you know, there's one here, and then the bottom stack has got a couple as well. So there's, you know, there's 4 fuses, 1, 2, 3, and 4. So the bottom one's exactly the same, but I don't think I actually finished talking about this, so I'll just zoom in here. So we got a solid state relay essentially to do the pre-charge, and then we can click in the contactors. To measure this side of the battery pack, or this side of the contactor, we'll be using the Leaf BMS here, which will calculate all the cells, just we'll add them together. For the total stack voltage, so we'll know what that is for one side of the contactor, so we can know when we're done pre-charging. We also have a current sense. The Leaf BMS only had a single current sensor in it for the whole pack, and I needed 2, so I ended up, this is another eBay find here. I got these guys, which are, if I can get it to focus, they are, there we go, CSLA 2DJ, made in Mexico. These are 225 amp plus or minus current sensors, so they'll do positive or negative 225 amps, which is perfect since I'm fusing at 200 amps. And even though it's a 200 amp fuse, you can probably have to pull at least twice that to get it to pop. There's a graph that shows you how long it takes to pop it. These are used, I think they came out of some solar installation. These are actually silver coated, and they've tarnished, so I can clean them up. I'll clean them up before I put them in. But yeah, current sensors will be read by the power controller, and essentially what it's going to do is if it sees an imbalance of current, so this power controller will be able to talk to the other power controller, and if it sees, and to the BMS, so if it sees that one of these cells is, say we're on the battery, we're charging, and one of the cells is gets above 4.1 volts, then it can open up that contactor to disconnect that pack, let the BMS do its balancing, and bring that cell back down while the other guys are still charging. You know, over time we'll get it all completely balanced out. And same thing if we're drawing a bunch of current and all of a sudden one of the cells is reading below 3 point whatever volts, then we can open up the contactor too to protect that pack. Or if one of the cells dies, or if anything happens to any cell, we can disconnect that pack from the system and still run off the other 3. So I think that's pretty good. Same with current. We can monitor the current through all 4 stacks. So if there's an open circuit in one, we can see, hey, that pack's not getting any, is not pulling or pushing any current. We can open that up and flag that as a warning, you know, whatever. So I think that's going to be pretty good. So if we, let's see, next we'll zoom in over here. So my motor controllers are all AMC 320s. They don't, I just realized that this is wrong. It's RS422. But I'm going to make a little RS422 to CAN, which is funny because CAN is actually RS485. So I probably, that's what I was thinking when I did that. But anyways, inside the motor controllers, there's a debug port. It runs RS422, and we'll be able to get everything that Monlog prints, and we can pump that over to one of the multifunction displays on both of them. So I'm going to build a little adapter, put these guys on CAN bus, mainly for display reasons. I might even hook it up so that I can disable the drive. So if I do have to open up one of the contactors, I can momentarily kill power or not kill power, but throw the motion interlock on it, so it'll disable it, open up the contactor, and then click it back in, you know, kind of a deal, or reduce power, limp home mode. So there's lots of options. This section is the battery chargers. I say plural because right now I only have one battery charger in there, but I'd like to put a second one in. And I've got BC3300s. I don't think there's actually enough room for BC3300. That's NLG4 charger. I'd like to get two NLG511 chargers. I have an NLG513 charger, but it's too high a voltage. So if anybody wants to trade a high voltage, like 360 volt, 380 volt charger for the 180 volt version, I'd be interested in that. Let me know. So I got two of them here. We're gonna have a J1772 port. I have that already. I didn't bring that down the show. But I've got a J1772 port. We're going to take advantage of some of the free charging around town. And this controller will talk to the both over CAN bus and, I don't show it, but on the J1772 port to the charging station, and then figure out what it can provide. So if it's got 120, or if I just plug into the wall with 120, then I'll click in one relay and we'll power up one charger in 120 mode and only pull like a kilowatt. If we plugged in 240 and we're not at a J1772, we're just plugging into the wall, we'll just fire up one battery charger to pull 3.3 kilowatts. And then if we've got a high current charge station available, we can click on both chargers and charge at 6.6 kilowatts, which would be pretty cool because we got a lot of battery in this truck now. Got to charge it. So I think that'll be neat. And I might put some smarts in there so it alternates between the two chargers. It's also part of the safety system, so essentially while we're charging, it can read, the charge controller can read the battery, the BMS voltages as well. And so if it sees one go too high, it can go and if one of the cells goes too high, we can open up that pack, right? So we can disconnect the packs. But if for some reason that wasn't working, then we can go tell the charging station to shut down. And if for some reason that doesn't work, we can always open up the contactor, which provides AC to the battery chargers, and kick them out of the loop too. So there's 3 levels of safety. I think that's going to be pretty good. So the next section down here, boy, this video is getting pretty long. This is the center console. This exists in the car already, but I'm going to make a little circuit board that'll put it on CAN. This will also be my Wi-Fi connection so that I can bootload everything that's in here over CAN bus. This will be the connection to a laptop or your phone or whatever. Center console already has access to the current shunt. It's got a little voltmeter in there, current meter, and so it's got high voltage coming in. It's got key switch coming in, and dimming. The meters in there have incandescent bulbs that are powered with 0 to 12 volts from the dimmer, the vehicle dimmer, and so we can pick that up with an A to D channel and send that over CAN bus so that all the displays know to dim. So we'll just pick that up there. Pick up key switches also comes in there. We'll get our amp hour counter, which is on a current shunt, which is going to be more accurate than the one that's using the Hall effect current sensors I showed earlier. And of course we've got the high voltage because the voltmeter reads that. So we're going to pick all that up, put that over CAN, and with the high voltage, that essentially tells us what the main 150 volt DC bus is doing. And with that information, we can now use that. The power controller now knows the voltage of this stack, and with the voltage of here, it knows the voltage on either side, so it can determine if it needs the pre-charge or, you know, can turn on these contactors. Since it knows essentially the voltage of this bus, the voltage of this bus, and the voltage of this bus, it can make its decisions based on that. And then the last part here are all these little, well, we'll do this, actually, do this section first. So in the vehicle already is a 150 volt to 12 volt DC to DC converter, buck converter. Because we can open up all 4 contactors while we're charging, to let balancing and things occur while we're doing other stuff, we're going to need to have the ability to essentially charge this 12 volt battery. So we're going to have to modify this or make one or do something else. And we're just going to have a little 12 volt auxiliary battery, which will allow us to power the vehicle, because we can't bootstrap. We got to flip these contactors in to get the high voltage across. So this is how the Leaf does it. They've got a little extra 12 volt auxiliary battery that actually powers everything, gets everything all up before the main DC-DC converter provides power. I think it'll be rare that I'm actually opening all the contactors, so we'll see what happens in that design. And then of course this little section here is the 2 150 to 380 volt DC-DC converters, and essentially I got one in the front, one in the back, and they provide power to the heaters. And the interesting thing is I've got a relay here to do that, but I might make 4 of them and individually power the battery heaters so that we can, I don't know if one side's hot and the other one's not, we could do that. And I don't know, it depends on how much granularity. I don't even know if I need the heaters yet. Probably will. And like I said, I could always bridge rectify the 240 volts. Except at work where it's going to be really cold, we only have access to 120 volts, so I don't know. It's one of those things where we'll see what happens. That might be like a different phase. It's going to work in different phases. Over here we've got the multifunction displays. These are going to go inside the dash. Next, 2 on the left side of the speedometer and 2 on the right side of the speedometer. And we can display anything we want on them. That's why they're multifunction displays. These are going to be full color, either LCD or OLED displays. Haven't decided yet. I haven't sourced these yet. And then this section are my switches. They're actually the smart switches. I've got a bunch here. I'll show you what those look like here in a second. And I got a couple smart switch controllers on CAN bus, so they're just going to read the switches. These switches have LCD displays in them and bicolor LEDs, so they'll be pretty cool. I'll show you that in a second here. And we'll be able to, essentially, I got one bank here with 4, and these are going to control the contactors. So essentially, you click that in, it'll be red if the contactor is open. So the 4 contactors equivalent to these 4 switches. So yellow means you're pre-charging, red means the contactor is open, green means the contactor is closed. So that'd be pretty simple, and then I can display on the LCD panel, like, I don't know, I don't know. Essentially, I can do everything on the multifunction displays, but I'm probably not going to have those in yet. These I've already got. The other buttons are actually just buttons to cycle through the multifunction display, so you can click them and they'll cycle through what you want to display. The motor controllers, you got batteries, waterfall graphs, voltage, current, speed, acceleration, I don't know, whatever you want to display on there, we can do that. But these, so let me do this here. So these are the smart switches, and they're really cool. And I got a whole bunch of them on eBay for super cheap. Oh, look at all of them. Ta-da. So let me grab, there's one of them in here I've already taken out of the packaging. I don't remember which one it was, so we'll grab this one. Hopefully that's it. So, where are we at here? So what these are, a little LCD panel on them. It's a 36 by 24, and it's a nice push button switch. And they got a bunch of pins on them. So it's SPI to them, and you can write to the display. It's graphics, there's no character ROM in it, so you can make it do whatever you want. And there's a couple bicolor LEDs in there, so you got red and green, and then you can turn them both on at the same time and get yellow. So that's what I'm thinking. It'll be a green background with text on there. When the contactor is closed, then you click it and it'll open it and it'll turn red. And then it might even tell you like if the contactor opens up because of an overvoltage, so it'll turn red, and I can say cell 42 overvolt, you know, something like that. Actually, I don't have 42 cells. Stack A, or pack A, cell 15 overvolt, you know, something like that. Or I can make it scroll through or do whatever. It'd be pretty cool. I don't know. I love these switches. They're awesome. I think more people should use them and stuff. But yeah, it'll be pretty neat. I'll probably grab, what I'll do is, I've got one of my little servo controllers / development board, so I'll probably rig this up to make that work. And then that will, yeah, that should do it. Wow, this video is already 21 minutes long. Well, you know, it'd be kind of cool is if we took one of these out to the truck and I could show you where I'm going to put them. So I think I'm going to do that. So pause. Actually, hold on. Before I do that, I think that covered everything on here. But yeah, that is the proposed schematic, subject to change without notice, and yeah, I think it'll be pretty cool. Yeah. Okay, I'm going to go ahead and pause it, and we'll go out to the truck. I'll show you where I'm going to put these switches, because there's the perfect spot for them. So, 3, 2, 1. Okay, welcome back. We're in the truck. So the spot that I'm talking about is right here. These 4 spots. I think I'm going to put 2 here, 2 here, 2 here, and 2 here, and I brought one of the switches. 1 there. So, yeah, it's a little dark out here. I don't have a light. The light is on in the truck, but it's not very much. But yeah, 1 there, 1 there, 1 there, 1 there. So the bottom row, I think, will be my contactor controllers. And then this upper row, I think, will be the multifunction display. And if you look, the 2 grays, they're the same color. It's perfect. Everything matches. You couldn't have gotten it any better. It's perfect. Ah, I like it. For the displays, well, it's kind of hard to tell, but there's like no light. I should have turned the light on the phone. But you can see I got a lot of room over here on the right and left side of the speedometer. So I'm thinking either one big like cell phone display on either side, long one, you know, 16 by 9, or 4 little ones, which I don't know if you can tell, but there's actually 4 little round gauges. If you look at some of the other pictures, they're removed, and it's got like this little piece of electrical tape that's covering it up. Unfortunately, there's some icons up there that light up that tell you, you know, I don't have my keys, so I can't turn on the car. But little icons like, you know, fasten your seatbelt and airbags, you know, that kind of stuff that lights up. But yeah, I don't want to cover those up. But I think there's plenty of room. I mean, look at the size of the switch here, right? So I think I can get a bunch of stuff in there. But anyways, yeah, I like this. I like the fact that the gray is like exactly the same color too. It's going to be pretty awesome. So I could even mount them this way, but I think they're designed to go this way with the viewing angle. So yeah, and then they'll be nice clicky switches. And there's lots of room back here because I took that apart on the and put the daytime driving lights circuit in when I worked on the other E10. But anyways, yeah, I think that would be pretty cool. Yeah, this video is pretty long. So anyways, thanks for watching. Bye.